Welcome to this comprehensive presentation on aircraft maintenance troubleshooting. My goal is to provide you with a deeper understanding of how to effectively diagnose and resolve common issues across various aircraft systems. This session isn't just about identifying problems. It's about understanding the why behind them, ensuring we maintain the highest standards of safety and reliability in our aircraft. We will cover not only the discrepancies and their potential causes, but also the detailed corrective actions and essential test points to consider during maintenance. This presentation is based on an extensive document that covers typical discrepancies found in power plant, instrument, comm, nav, electrical, and pneumatics systems. What sets this guide apart is its practical approach, outlining not just the problems, but the step-by-step processes for identifying probable causes and implementing effective corrective actions. Our objectives today include enhancing your diagnostic skills, familiarizing you with key inspection points, and ensuring consistent and reliable maintenance practices. Let's get started by understanding the core systems with the power plant system, the heart of any aircraft. This encompasses the engine, propeller, fuel, oil, and control surfaces, essentially everything that makes the aircraft fly. We'll explore common issues, focusing on how to accurately diagnose problems like engine vibration, RPM irregularities, and fuel pressure anomalies. For example, if you encounter engine vibration, don't just jump to conclusions. The probable causes can vary widely, from something as simple as defective spark plugs to more complex issues like propeller damage or even internal engine problems such as uneven cylinder compression. The corrective actions are equally diverse. Spark plugs start with a bomb check to identify fouling or damage. Clean or replace as necessary. Engine to magneto timing, incorrect timing can cause significant vibration. Synchronize the timing meticulously. Fuel lines and to foreign object debris in the fuel lines can disrupt the fuel supply, leading to vibration. Drain, flush, and thoroughly clean the lines. Engine shock mount. A loose or cracked shock mount can transmit vibrations throughout the airframe. Retighten or replace as needed. Cylinder compression. Perform a compression test to identify cylinders with low compression, which can indicate internal engine wear or damage. Propeller damage. Inspect the propeller for any signs of damage, such as cracks, dents, or imbalances. Remove or replace the damaged propeller. Similarly, high or low full power RPM can be caused by an improperly adjusted or defective propeller governor. The corrective action involves adjusting the propeller governor, screw to the specified range, or replacing the governor entirely if it's defective. Always consult the engine manufacturer's specifications when making these adjustments. Following these detailed steps ensures a thorough and accurate diagnosis, leading to effective and safe repairs. Moving on to instruments, these are vital for providing accurate flight data. We'll focus on how to troubleshoot issues affecting flight deck displays and sensors, emphasizing the importance of precise readings for safe flight operations. We'll cover problems such as unresponsive airspeed indicators and abnormal oil temperature indications. An unresponsive airspeed indicator can often be traced back to a clogged pitot line. Here's how to address it. Pitot line inspection. Carefully inspect the pitot and static lines for any visible blockages. Clearing blockages, use compressed air to flush out any obstructions in the lines. Be gentle to avoid damaging the sensitive components. Indicator replacement. If the problem persists after clearing the lines, the indicator mechanism itself may be faulty, requiring replacement. For abnormal oil temperature indications, the issue could stem from faulty sensor or wiring. Inspect the oil temperature sensor circuit for any signs of damage or corrosion. Grounding issues. Poor grounding or loose power plug connections can lead to inaccurate readings. Ensure all connections are secure and clean. Sensor connector replacement. If the sensor is defective or the connector is corroded, replace them to ensure accurate temperature readings. Accurate and reliable instrument readings are crucial for safe flight operations. By systematically checking and addressing these potential issues, we can maintain the integrity of our aircraft's instrumentation. Now we'll explore communication and navigation systems, which are essential for safe and efficient flight operations. In this section, we'll address radio and navigation equipment failures, focusing on systematic troubleshooting to restore functionality. If you experience no radio reception, the cause could be multifaceted: component replacement, faulty comm, NF transceivers, defective headset adapters, bad pilot, co-pilot jacks, failed PTT push buttons, and faulty VHF antennas should all be individually tested and replaced as needed. Electrical continuity, a critical step, is to check for electrical discontinuity at connector points, particularly between the transceiver and antenna. Restore continuity to ensure proper signal flow. IC replacement, defective GMA 340 integrated circuits can also cause reception issues. Replace the IC to restore functionality. Similarly, an inoperative navigation indicator may require indicator receiver replacement. Test and replace the navigation indicator or receiver as necessary. Continuity restoration. Ensure there is electrical continuity between the receiver and indicator. VOR unit replacement. If the VR very high frequency omnidirectional range unit is defective, it should be replaced. Properly functioning comm, nav systems are crucial for maintaining clear communication and accurate navigation. By addressing these common issues systematically, we can ensure safe and efficient flight operations. Let's examine the electrical system, which is crucial for various aircraft functions. From safety warnings to actuator operations, we'll focus on electrical warnings and actuator issues, providing detailed troubleshooting steps to maintain system integrity. Silent stall warning horn can be due to horn replacement. The most straightforward solution is to remove and replace the horn. Transmitter replacement. If the horn is functional, the stall warning transmitter may be faulty and require replacement. Unusual sounds from the flaps assembly often indicate actuator assembly replacement. A worn or damaged flap actuator assembly is a common cause. Remove and replace the assembly to ensure smooth and reliable flap operation. For a landing gear warning light that is not illuminating or illuminated when the gear is fully retracted, deployed, control panel replacement. Start by replacing the landing gear control panel. Rigging and switch verification. Perform rigging per the maintenance manual and verify the switch operation. Block switch and transit light inspection. Check for defective uplock switches or faulty transit lights. Reliable electrical systems are vital for the safe and efficient operation of an aircraft. Systematically addressing these potential issues, we can ensure continued integrity of the aircraft's electrical components. Lastly, we'll cover pneumatics, specifically shock strut pressure problems. Properly functioning shock struts are essential for safe landings and taxiing. We'll discuss how to diagnose and correct common issues to maintain optimal performance. If you find low pressure in the nose gear shock strut, it's typically due to fluid and gas service the hydraulic fluid and nitrogen gas as per the aircraft specifications. Component overhaul the affected component to ensure it functions correctly. O-ring replacement. A damaged O-ring can cause leaks. Replace the O-ring to maintain pressure. Ensuring the pneumatics system is in good working order is crucial for the safety and comfort of each flight. By conducting regular checks and addressing issues promptly, we can maintain the performance and reliability of this essential system. To summarize, our troubleshooting approach consists of 4 key sections. 1. Discrepancy identification, pinpointing the exact issue through careful observation and pilot reports. 2. Probable causes, investigating the most likely causes based on the symptoms and system knowledge. 3. Corrective actions, implementing the necessary repairs or replacements, following approved maintenance procedures. 4. Test points evaluation, verifying the effectiveness of the corrective actions through thorough testing and functional checks according to the manufacturer's specifications. By systematically addressing each of these areas, we can ensure effective and reliable aircraft maintenance. That concludes our in-depth presentation on aircraft maintenance troubleshooting. I hope this overview has provided you with valuable insights and practical knowledge to effectively address common aircraft maintenance issues. Remember, thorough diagnostics and systematic corrective actions are key to ensuring the safety and reliability of our aircraft. Thank you for your attention and have a great day ahead.